Okay, this is our first note of the static electricity, or static and current electricity unit, the first of 15 notes. And today's date, well, you will enter your date, I believe for me, that would be March 25th. And as I said, this is lesson 1, and we're going to follow up this lesson by considering 4 related assignments that you will have to do in class. So, the first thing we're going to do is look at properties of the particles in the atom. Now, we learned this in the chemistry unit. The first particle that we'll consider is perhaps the most important overall to define any type of atom, and that's the proton. It is the positively charged particle that is inside the nucleus, and we'll consider it with the symbol P with a plus, or sometimes just the plus, depending on if it's a picture or if it's in text. If it's inside of text, we'll do P with the plus, and if it's inside a picture, we'll just draw a plus sign for positive charge. The second type of particle that's inside the nucleus is the neutrons. And from our perspective, there's no charge, has very little relevance to the electricity part of the course. It is also in the nucleus. And if we do write it down, N, or N with a little O to represent, or 0 to represent zero charge. The third type of particle is the electron. And it has negative charge. It is outside the nucleus, which is really why it's the one we care about the most. The negatively charged electron, if you notice, electrons are the main component of electricity. The symbol for the electron is an E, often with a little negative sign up as a superscript. Now next, let's just look a little bit at the structure of the atom, and we know all this. You'll see in the inside of the nucleus, in the middle, you've got the protons and the neutrons, and they're tightly held together. And the fact that they're tightly held together is very important, compared to these electrons around the outside that are free to roam around the atom, and quite frankly almost free just to take off. And it's when the electrons leave the atom and move from atom to atom that you have what's called electricity. So electricity is really moving electrons. Usually it's these valence electrons, the ones on the outside, that do the moving. They're called valence electrons. And they do all the moving. So, some things that we want to keep in mind then is that these protons that are in the middle, they're very tightly held, they do not move. So electricity is not caused by moving protons. Electricity is caused by moving electrons, and from our point of view, positive charges stay put. They are stationary. Negative charges move. And it is really important to understand that the reason for that is that the negative charges are outside the nucleus, they're free to move. There is a bit of a force of attraction you can imagine between positively charged protons and negatively charged electrons, but that is not nearly enough to keep them in place. Unlike what's called the strong force inside the nucleus holds the protons and the neutrons together. So moving on, so what is electric charge? And this is actually a very, very complicated question, but I'm going to give it the best definition I can, which is electric charge is really an imbalance or an uneven number of protons and electrons that results in electric force. Okay. We talked about that in chemistry. You could have a negatively charged ion if an atom had given up or gained electrons from another atom. So the law of electric charges is something that most people know by nature, that positive similar charges repel and like charges attract. Unlike charges attract. And so when we think about this idea of an electric force and repelling and attraction, imagine you had two objects, maybe two little light balls, and one of them had a positive charge and one of them had a negative charge. Those two objects would experience a force towards each other, and that's the electric force. So there's this force called an electric force that causes objects with different charge to attract each other, or repel if they were similarly charged. Okay, so moving on, just a few summary notes then. Neutral objects have equal number of electrons and protons. Positively charged objects have more protons than electrons. That's what makes them positive, more protons. And negatively objects have fewer. So it's this unbalance of electrons and protons that causes electric charge. I've told you already several times, it's electrons that move. Okay, static electricity. What's static electricity? Well, by definition, static is non-moving. And that's more or less what static electricity is. It's usually a buildup of electrons that aren't going anywhere, or charge that's not going anywhere. You get a buildup of electric charge on some object. A great example might be on a big cloud. So a huge buildup of excess electrons. And eventually those electrons, because they repel each other, are going to create, at some point they just can't stay up in the cloud. They're going to have enough energy, they're going to jump to the ground. And that would be what you call lightning, or in any case, a static shock. You would get the same thing if you, you rub your feet on the carpet, building up electrons on your body, get near a door handle, and those negative electrons in your body, or the buildup of electrons in your body, wants to jump away. So it causes electric shock. And like I say, shock could be, in the case of a lightning, it could be just a simple little shock between your finger and the door handle. It can mean a lot of different things. All right. So out of the definitions and into something that we need to understand in order to understand how an object gets electrically charged, because there's certainly a few ways. And the first thing that we need to understand is something called charge separation. So charge separation, what is it? Well, it basically means you have a neutral object that has one half of it is positive, the other half is negative. Well, how can that happen? Take this, and we'll call this a little neutral sphere. Imagine this is a tiny little sphere, a little ball. So neutral. And imagine inside this neutral sphere, I had a neutral, so I had electrons and protons, so I'll represent my protons, and obviously there'd be, no matter what size it is, there'd be billions and billions of protons, but we're going to just say there's 5 for picture's sake. And if it's neutral, then pretty much where there's every proton, there'll be an equal number of electrons. So that would be my neutral sphere. Sort of everything's evenly distributed and everything's just what you'd expect to find. Now, this gray thing here is supposed to be what we call, I'm going to call it an ebonite rod, but it's some charged rod that has a negative charge. And I say negative because if you look at the rod, it's got 1, 2, 3, 4, 5, 6, 7, 8 negatives, at least by picture. Again, it would be billions and billions, but if you just look at it, you can tell it's negative because there's only 4 positives and 8 negatives. So this is some rod of some sort that has a negative charge. Now, here's my neutral sphere again, and so it still has my protons, and I will remind you that protons don't move. Well, they do, but from our point of view, they don't move. The positive charges don't move. But if I bring this negatively charged rod close to, on this particular side, on this half of my sphere, what's going to happen is that the electrons that were over on this half of the sphere are going to crowd away from it. So all of a sudden I'm still going to have 5 electrons, but they're all going to be on one half of the sphere. And now if you look at the sphere, this side now has more negative. So this is a negative side of my sphere, and this side is more positive. So it's going to be the positive side of my sphere. And so inside of this object I've created what's called charge separation. And it's just a bit of an introduction to really how we start to detect charge and how we create electric charge. And again, this is going to lead us to a stronger understanding of electricity in general.